Okay, good afternoon, everyone. In the beginning of the class, let us see the new announcement. Okay, there is one new announcement today. This week's classes have been changed to online classes. Hello everyone. This Monday, March 7th, 2022, my body had some problems. I asked my neighbor to call an ambulance for me, and I was sent to Daling Cuji Hospital for treatment. I was discharged at 9 a.m. yesterday, March 8, 2022 morning. After the doctor's diagnosis, he thinks I should take more rest. I have requested leave from the department from March 8th, Tuesday to 11th, Friday 2022. All courses during this period will be changed to online courses. I will videotape the content of the course, upload it to YouTube, and announce the URL on the eCourse2 website. Students do not have to come to the classroom to attend class. I apologize for any inconvenience caused. Best regards, Wei Zhen. Okay, so let us continue the progress of the class. Okay, in the next previous class, we have taught to chapter 1, slides page 130, problem 1, solution, point E. Okay, so let us continue the progress. Okay, because I do not have a blackboard with me, so I use the Word instead. Okay. Okay, and P of r theta is the bivariate Gaussian density function expressed in polar coordinates. For the assumed additive narrow-band white Gaussian noise having independent in-phase and quadrature components, PR of theta is Okay, P of r theta is equal to, okay, this should be italic. Okay, r over 2 pi sigma square and times exponential minus r square over 2 sigma square. Substituting equation 2 into equation 1, we have the following equation. Okay, so Pm is equal to 2 times the integration from 0 to pi minus psi, and the integration again from capital R to infinity, R over 2 pi sigma square times exponential minus R square over 2 sigma square dr d theta. Okay, next, note that Okay, note that the differentiation of exponential minus r squared over 2 times sigma squared with respect to r is equal to exponential minus r squared over 2 times sigma squared times minus 2r over 2 sigma squared. Okay, and this is equal to minus r over sigma squared times exponential minus r squared over 2 times sigma squared. Integrating both sides of equation 4 with respect to r, we can get integrating both sides of equation 4 with respect to r, we can get after integrating it with respect to r, we get exponential minus r squared over 2 sigma squared. And this equation becomes the minus integration of r over sigma squared exponential minus r squared over 2 sigma squared dr. Multiplying both sides of equation 5 by minus 1 over 2 pi, we can get okay, minus 1 over 2 pi times exponential minus r squared over 2 sigma squared is equal to the integration of r over 2 pi sigma squared times exponential minus r squared over 2 sigma squared dr. Okay, we call it equation 6. Okay, then okay, then this equation integration from capital R to infinity r over 2 pi sigma squared times exponential minus r squared over 2 sigma squared dr. Okay, is equal to okay, is equal to minus 1 over 2 pi times exponential minus r squared over 2 sigma squared, and the lower limit is equal to capital R, and the upper limit is equal to infinity. Okay, and this equation equal to minus 1 over 2 pi. Limit r approaches infinity. Exponential minus r squared over 2 sigma squared. And minus exponential of minus capital R squared over 2 sigma squared. Okay, and obviously this limitation is equal to 0. So we get this equation. So finally, this is equal to 1 over 2 pi times exponential minus capital R squared over 2 sigma squared. Okay. Okay, then substituting equation 7 into equation 3. Okay, let us go back to equation 3. Okay, this equation. Okay, we can get okay, it is 25 minutes. Let us take a break.